Hello, I'm Michael Gaucher, and it's January 25, 2026, and it is the winter storm, and work is shut down for a couple of days. But my work never ends. I'm always studying, I'm always researching, thinking, and planning for the future, as well as executing. So one of the things I've been executing on is a couple of things that is relevant to many of us on the journey of leveling up our careers, leveling up our lives, leveling up the ways that we do things using the tools and opportunities that are available today. So one of the things that I work in is software development. And as I mentioned in my last video, I got my hands full going through some .NET books, right? And basically, some of these .NET books, they are pretty old. Like, I think this one's from, 9 years ago or something like that. Or at least that's the last time I had read it. And so I'm rereading some of the old books that I've read because I found that over time, what ends up happening is you become so accustomed to doing things a certain way that you forget the terminology, you forget the original reason why you do certain things. And in some work practices, in some industries, I guess that's okay, but that's not okay in software development and technical trades. And so it's very much like the medical field, where you have doctors, or the legal field where you have lawyers, where you have to know the terminology, you got to know the rules and the policies. It's not enough to just have talent. And there is an abundant amount of talent in software development, but there are instances where a person either cannot prove their talent in conversation or prove their expertise in conversation because they've lost sight of or have forgotten the terminology, the jargon, the lingo, the way you phrase things. And so part of my deep dive into my old books and the new books as well is to reinvigorate and resurface that information in its original forms and in its modern forms, so that I can more effectively articulate these things in conversation as well as in planning. And the planning part is important when we do use tools like AI, where using the right terminology can reduce the amount of tokens that you have to use. When you type a sentence in a chat window, let's say for ChatGPT or Gemini or Claude, when you type your sentence, your prompt, it does not 100% go through as the sentence that you typed. It gets translated into these things called tokens. They are numerical values that are then looked up in a database to find the most relevant response, relevant information and relevant response to bring back to you. Well, generating these tokens and processing them can be very expensive for a computer. It can take a lot of power for a computer to do this conversion process. So the more efficient your prompt is, the better the result you're going to get. And in many cases, you can get no better the result than when you are very clear, accurate, and precise in your prompting. And so part of the reason for me to reconsolidate my knowledge, to rebuild my knowledge in terms of the terminology, the way you describe the concepts, is so that I can use these tools more effectively to the extent that I use them. And so the other reason why it's important to do that is you want to make sure that when you're writing code manually, because despite everything that's being said about the progress of AI for software development, writing code manually remains and will remain very important, because AI can only work on what is known. It does not work very well, if at all, on the things that are not known, that is, not known to it. Because not everything about software development is on the internet. Not everything about software development is in GitHub, GitLab, or Launchpad. So there is an immense amount of information about software development that you that some companies consider, that many companies consider, proprietary trade secrets, intellectual property, governed under non-disclosure agreements, whether you're talking about military defense, aerospace, and certain industrial applications, pharmaceuticals, and healthcare. And so you're going to have information and knowledge that the AI simply does not have access to. And there are expert techniques that people know, but is seldom, if ever, verbalized, articulated, even on videos. There are billions of videos on YouTube. And even in that vast catalog, you're going to find that there is an absence of certain techniques, certain ideas. So not everything exists on the internet, whether it's in the form of a web page, a PDF, or a video, or a blog post. It's just not there. And there can be legal, national security, and just straight out, opportunity reasons for that to be the case. So for the known patterns, AI does very well. And many of the known patterns also exist in books. So the extent to which you are literate in software development will have a huge impact on what you can extract using AI. And what you're extracting is not only capabilities from known knowledge, but extracting from your own self. That is, can you even explain to your own self what it is you're trying to do in a way that can be translated to a technical result, a technical implementation? And this also goes beyond software development to any area of life. You know, if you're running a business, if you are managing a sales team, if you are managing an operations team, if you are trying to optimize and enhance the way a warehouse works, the way a manufacturing organization works, how well you understand the details has a huge impact on how well you're able to formulate plans. And of course, that drifts into the conversation about leadership versus management, right? If you talk about leadership, right, on the one hand, you got leadership versus management, right? So leadership deals with the high level. It deals with the vision. It deals with motivation. And it asks the question, what should we be doing? What should we be doing? What is the direction that we're going to go in? That's what leadership deals in. Management deals with the details, the process, the steps, administration. And it's dealing with the question of how do we get there and in what way? What's the correct way to do that and to maintain that? So management can largely be fixed whereas leadership can be much more organic. And in the real world, these can combine, they can fuse, but they can fuse together. But it's helpful to know that there is a distinction, and that distinction is real. And the higher up you go, the more you see leadership. And then, ironically, the further down you go to, let's say, the ground level, where you're dealing with what you might call a lead, you also see leadership, hence the short abbreviation lead. Leads, by definition, in corporations and most business processes, at least in the US, by definition, a lead is not a manager, though they're often in management. So a lead, you can tell a lead when that person can guide others, they can give direction to an extent, but they're not the person that does write-ups. They're not the person that enacts discipline. That's the job of a manager. Manager deals with, okay, are we sticking to the rules? And if we are deviating from the rules, which impacts the business, then we need to exercise accountability, right? So there's a huge difference between management and leadership. One is not better than the other. You need them both. The general that leads an army, get it? Leads an army, needs lieutenants and majors and colonels that are going to manage the actual engagement, the supply chain, whatever it is, to win, right? So when we're dealing with any process, we're also dealing with that division as well, right? And so when we're dealing in software development, the product development side of it is a leadership course of action. What is the vision? What should we be building? What is the landscape in which we operate? And what are going to be the best set of principles that's going to get us there, right? And then we communicate that and enlist the support and participation of others to make that happen. And then when we execute it, software development management, notice you rarely hear about software development leadership. Most software development topics come under the visage of management. How do we execute? How do we deploy? How do we track and measure what we're doing? Software development has a very strong alignment with management. So, in order to do that well, you have to make sure you remain apprised of the details, right? And so I like to point out these particular set of books because, that's what I'm working with right now, is to make sure that my .NET acumen is at its highest level. But there are other books that you'll want to concern yourself with, right? You got to know how to write great code. You got to know what the philosophy is around software development. You got to know these things, right? And then knowing those is going to help you get to the right level. And so, knowing about your computer, your computer architecture, so that you're not just, dealing with things at a surface level, but you're dealing with it at a deep level, right? And, every now and again, just going really deep and understanding, what is and what isn't, right? And so the ability to do these things is very vital, right? If you're going to do web development, I definitely recommend reading Ben Frain's book, Responsive Web Design. It's a very, very useful description of HTML5 and CSS and where it has gone. And so, I just got all kinds of stuff, going on. But the thing about that is, I am looking at software development and where it seems to be going. And I say seems because there is much talk about about AI-driven software development. And so I've been looking at this in earnest. And so to remember where I started this conversation, I started with, individual competence. And we got to keep that in mind as we go along. AI tools do make things, or seem to make things, easier. But I've used AI for 3 years, and I've used it in a certain way for 3 years. There's several different ways to use the AI. You can do chat, which most people are familiar with. Chatting with an AI, and most of the time you do this on the web or mobile, right? So you're just talking with it, and that's your Copilots, your Chat GPTs, your Google Geminis, that sort of thing, right? So yeah, Chat GPT, Gemini, and just Claude in general, right? And so you got those, even DeepSeek. And so you can do all of these mobile, or you can do them just in a web browser. So then the other way that you can do it is what's called CLI. That's going to be a new term for anyone that only knows about AI in this way. CLI, that is, you're doing things on a command line. All right, and you're talking directly with the LLM, with the AI. It's a very direct interaction. It is very granular. It's very detailed, right? In the actual movements, the mechanics of it, right? It's not something where you click, you type in a box, and you hit a button, and you go, and you get a response. There are many more pieces when you're dealing with the AI in this way, okay? And then you also have something where it's just a full-out agent, which can mix some of this together, but it's its own thing, agent, or agentic AI, right? And so this is more or less automatic. That's automatic. You get it started, but then it goes off and it does its thing, and you're not sitting there waiting for it. You can walk away, you can close things down, shut your computer down. You come back, you open it back up, maybe a couple of minutes later, a few hours later, and it has something ready to go for you, right? So that's agentic AI, right? And so those are the three main modes that you have, and then you got some variations on all of that. So the thing about it is I spent 3 years with a chat, right? And there's a lot that you can learn from that. There are many capabilities that the different AI providers put in their chat-based tools. But to get the most out of it, you really want to do it this way. So you want to be on the command line. So I've specialized in command line programming, going all the way back to, at this point, 2008, 2009. I started this channel, in fact. My very first videos on this channel, the foundation for this channel in the beginning, is CLI programming. So I was an early advocate for CLI programming when it was less popular. And so I'm glad to see that everything has shifted more to emphasize this. I've watched over the years as this has increased. So CLI programming, that gives you the most control over what it is you're doing. Now, you can use the CLI for things beyond programming. You can build presentations, you can build documents, you can build work processes. And in fact, most of your real IT engineering that happens, or that has happened over the decades, has happened here, invisible to most individuals. And many programs that are built, they start out this way, and then they may evolve, and you might go from here to what's called GUIs, graphical user interfaces, right? So a graphical user interface is point and click. You can see things on the screen. So graphical user interfaces are very accessible, but there was a belief at one time that software development would be more accessible to more people if you focused on graphical user interfaces for software development. So then that's where you got Visual Studio. That's where you got a number of tools for interacting with databases like Microsoft Access and its larger brother, SQL Server. SQL Server runs in the background as a CLI process, but in a Windows service on Windows in the past, and now Azure SQL in the cloud. But it runs as a CLI program, but you had a GUI that could talk to the CLI to allow you to manage it. So you can use these together, but the direction from Microsoft in the past was to really emphasize the GUIs, because they also emphasized Windows, which is itself this GUI system, this graphical system where you can point and click to do things rather than type commands, right? So let me emphasize that. Here, you have to type commands. So you're typing your way through to what you want to do. Whereas here, you're pointing and clicking, maybe talking, right? Or tapping and touching. So your mobile phone or your tablet, it's a type of GUI. So in the beginning of the computers, right, as we understand them, you know, there are different eras of history where you had punch cards, where you basically control the computer with these cards, and you just slot the card in, and the little holes were represented commands. You slot that in, and that made the computer do things. And then we grew from that, and we, you know, came up with some stuff that was easier than this, right? But then we later on came up with this, which was easier than that, right? But the thing of it is that as powerful as GUIs are, they never gave us the level of capability that you ultimately can get by being able to directly interact with the computer. So GUIs had their huge heyday in the 90s. You know, they sprung up in the 80s, but they really came to their real apex, or they started on their huge incline or rise in the 90s. And what we're seeing with programmers over the last several years is a swing back to the more direct route, because this way, when you work with a computer this way, it's actually faster. The more data you have, the more detailed process that you have, the more that you have to get into things to maneuver a project or a process in the right direction at a given moment, the more you need this. I'll give you a perfect example. Let's say I have a 10 gigabyte file. So I got a file. This file is 10 gigabytes, right? And let me fix that. I have a file that is 10 gigabytes. And it has like years of reports on it that is all zipped up. It's a 10 gigabyte zip file. So I got this zip file, right? I got a zip file, but it's 10 gigabytes. All right, so here I am. I'm on my computer, right? So this is my computer, right? And then I'm at work, and I need to take that file and I need to I need to copy it to a file share, to a folder on the server. That 10 gigabyte file, that could take an hour to copy up there, depending on the transmission speed. It could take longer, right? But it's usually not going to take less than that. It might take an hour, right, to upload that 10 gigabyte file. And even if it took like 20 minutes, that's still a lot of time in a work day where you're wanting to do something. And then what happens if I need to expand or extract that zip file and get all the data out of it, either here or here, right? Okay, so if I expand the zip file, right? So let's say it has 1,000 individual files in it. If I try to copy those 1,000 files up there, right, 10 gigabytes in total, that's going to take even longer than trying to put up that zip file in many cases. Now, here's a very interesting thing about computers. If I can calculate what the maximum latency is for a given file, if I can calculate how large a file needs to be in order to transmit at the right speed, at the right throughput from one source to an endpoint, right? So from an origin to the endpoint. If I can figure that out, I can actually shorten the amount of time it takes to move the whole thing. I've actually done this in IT work, where I had to move maybe a database backup from SQL Server on my local machine. Maybe I needed to back up my local database, and it was like maybe 100 gigabytes, whatever the case may be. Or maybe I had to deal with some critical report data, and we knew we had to have the report done by the end of the day. And I knew that would be impossible if this took too long in the workplace that I was in. If it took too long for me to even get the data up there, for the system to even process it, right? Because I can remote log into here as well, right? So the trick, if you want to call it a trick, but it's not a trick, it's computer science. If I can put this in the right divisions of data, right, have the right size, the right amount of size, I can reduce the amount of network back and forth that happens here, right? So that the overall payload arrives sooner than it would if I either left it like this or I left it in all of its little parts, right? Because there's too much communication going back and forth, too much management overhead on the network, right? Okay, so the thing about that is, the reason why I bring this up, so if I have Windows Explorer, the File Explorer on the computer, if I'm using Windows, and I drag and drop this, what's going to happen? Here's what's going to happen in that case. Let's use the right color for that. Y'all seen this. I'm going to have a green progress bar, right? And that progress bar is going to look like it's stuck. It's just, right? It don't matter if you you drag and drop this to the file share and you watch that and it just sits there, right? And you're like, man, what's going on here? And you're like, oh man, I done made a mistake. And you hit cancel. It takes just as long to cancel it as it is to try to get halfway. So you can't visually drag and drop this over there. You can't visually drag and drop this 10 gigabyte file over there. You might know a little bit about the network if you are a power user and not an IT person, right? You might know a little bit about the mathematics where you say, oh, well, let me calculate that and get that over there. But then, okay, so what? You was able to copy it up here faster, but you now still have a problem of, okay, I need to reassemble the file at the destination, right? Or I need to expand the file at the destination. Both of those are going to be a problem. Because as soon as you right click up here and say unzip, or you right click and you say zip, guess what Windows wants to do? It wants to run that zip or unzip process from the standpoint of your computer, not from the standpoint of up here. You see, so you got multiple problems that compound that prevent you from being able to do this efficiently using a GUI visually. So then that's where, your command line comes in, right? Where you got a black and white screen and you type in the commands, and maybe you can even write a little script, right? A .bat file or whatever, a script. And you tell the script, okay, you've written the script, and you say, okay, take this, unzip or zip according to the right size divisions that is going to efficiently upload here. And then let's use robocopy, because robocopy is going to be faster than drag and drop. You're doing all this in a script, you type the commands, and it takes a fraction of the time it would take to do this visually. The visual approach looks simple. Here's a file, drag, and you're supposed to be done. Nope. But I wrote this. If I sit here and I spend 10 minutes writing this, that 10 minutes writing that and then executing that is still going to take less time than it would take to try to visually drag and drop that if I don't already have this established. So then this takes a fraction of the time to get over from here to here, and then I can remotely dial into here and then finish the zip or unzip process from there, or even have a script there that takes care of that. And then maybe I have some type of program on Windows Task Scheduler or whatever. If it's Linux, you've got a systemd service, and it processes it, and you're done, right? So I had real world scenarios just like that. And there are far better ways to articulate that than I just did, right? But like I said, this is a very ad hoc conversation. So that right there, that scenario that I outlined, that's why people are emphasizing CLI and command line programs. That's why I started emphasizing it back in 2008, 2009. That's why my original videos on this channel, the very first ones that you will see, it really emphasizes and talks about this. And so, and those videos are from 2019. So the thing about it is, Claude Code is more effective than ChatGPT for these reasons that I just outlined. That you're able to work with your actual code files, which are on your computer. The code files, they're sitting on your computer, right? So once again, here's your computer down here, and you got two options. You can try to talk to an AI on the web, right? Or you can communicate with the AI server directly. Which one is going to be the best approach, right? So I got web AI and I got server AI. And I know technically there's no real difference, except that here I'm using a web browser to talk to the AI. And you're going back and forth, you're typing paragraphs or sentences, and you're waiting for a response, and you're doing that, you're uploading some code files, but you run into limits because there's limitations with how much you can upload efficiently, how much the web AI implementation wants to retain of that information. There's so many liabilities here in terms of the logistics of this communication. That's why it falls apart ultimately the more complex it gets. Whereas if I talk to the server directly, right, and I do that not with a GUI, and you can use a GUI. I mean, that's what Cursor is, right? Cursor is a GUI for talking to the AI server. But I can just basically open up my command line, type my commands, talk directly, and it can see the files. So I don't have any file limitations here. How many of you have used AI on the web and it says, oh, you can only upload 10 files, 5 files. We don't recognize this file type, blah, 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 right? That's part of GUI programming. GUIs have to consider the scenarios that it can support. GUIs are not unlimited, but you get closer to unlimited when you're working on the command line, right? That's another reason why I switched to that back in 2008, 2009 for my private projects and the way I work personally, right? So that's why Claude Code is so popular, and Gemini CLI, and that's why OpenAI came out with Codex, right? Because this is a much more efficient way to work with information. It always has been. So now you're talking with the server directly, and you're able to grant access to as many files as you want or need, and you can work with this process much more quickly, right? Nothing says that the different commands that you run, they don't have to be typed in real time. You can type up a script file. You can do a Claude Markdown file. You can do all kinds of things productively locally on your computer and still run that through the command line and be infinitely faster than you are with that. All right. So for those that haven't watched the videos out there on the internet that explains this process better than I have, right? That is a short intro to what Claude Code, Gemini CLI, and OpenAI Codex, what they really are, the rationale for them. Now, here's the thing. Even with all that productivity that we have there, right? It goes back to the question of, do you need software developer skills? Okay, so let's put it in black and white here. Write code. So it was a student or someone that asked Bruce Lee, I think it was Bruce Lee, and it might even been Jet Li, or both. They said, what's the most important thing in martial arts, right? And let me broaden this out, that there could be a number of martial art teachers that would say this. They would say a couple of things. One of the most important things in martial arts is to try to avoid a fight. That's like rule number one. Let's try to avoid a fight if we can, because there's high risks in a combat engagement. Combat interactions is a last resort, where all other methods fell apart. Diplomatic, speaking with someone with tact and respect, evasion, all of that. Okay? So then when it gets to the actual martial arts engagement, what's the most important thing? The most important thing is your mindset, sure, and how your body is centered and how you control your zone of centeredness, right? But even beyond the theories of martial arts, it comes down to one thing. How good are you at kicking butt, right? Can you kick butt? They say the A word, right? But can you kick butt? See, some people can study martial arts and understand the theory, and they can even see it in their head, right? But when they actually get in a combat situation, they cannot perform. And then you might have someone that has studied martial arts, but they haven't studied it to what you might call a master's degree or PhD level, maybe not even a bachelor's degree level. Maybe they just got like a freshman or sophomore level knowledge of martial arts. But when they fight, they can fight, right? And so it's kind of like, that's the basic thing, is you got to know how to fight. And let's bring it beyond martial arts. When you do your job, you got to know how to really do your job. there are what you might call other things involved in the work. There are other things that you have to consider. But when it comes down to actually doing the job at a very basic level, let's say that you are a janitor. Yeah, you can know about sanitation procedures and sanitation policies and all of that. But if you can't mop that floor really well, and you don't know how to really take out that trash really well and know where the opportunities are to really make things shine and clean and use the right, stuff to make it smell and make it pop, then, people are not going to be as pleased with you as a janitor. If you're working on a factory line, yeah, you might understand like the OSHA practices. You might understand all the rules of, how you show up to work and all this kind of stuff. But if you can't stack them boxes and pack those components, if you can't do that, it's like, man, you're not the best, So it's the same way with software development. So even though you have a tool that can write code on your behalf, you still have to know how to write that code. So here's a perfect example. Right? Okay, so let's take a Steve Covey analogy. Begin with the end in mind. So you got to begin with the end in mind. Where are you trying to go? That goes back to that leadership we're talking about. You're leading yourself in this case, but begin with the end in mind. What is the end goal, right? All right. So you know where you're supposed to end up, okay? And you know what this is supposed to look like. And you really know what that's supposed to look like. And you got a couple of ways you can go to get there. Today, when we're doing this, we can say, AI, do it for me, right? You can say, okay, I got this program. I got this computer program. And I got this source code. And even if you don't use AI, the AI is going to generate the source code, right? But depending on what type of program it is, you might have to compile it. So it has to be compiled. It has to be compiled, right? Or it's interpreted. But either way, it has to be translated into an actual program that would run on the computer. This translation step is mandatory. The computer does not understand source code, right? A computer does not know what Python, JavaScript is. It has to be translated. Okay, now, what if I had what you would call just raw binary? Okay, you could write that yourself. Nobody does. And the reason why nobody does is because this takes, and this is just an example, this takes 10,000 times more code to do the same thing that you would write in the source code, right? That then is translated, right? So when you have your source code ultimately gets translated into this. The source code goes through these tools. There are tools that we have as programmers that takes the code we write and translates them into this, which is the program that runs on the computer, right? So then what we're doing with AI, is we're trying to speed this part up. So the AI is then doing this, right? Which then still has to go through this, to go through this. So we're just adding another layer. So we already have tools that do translation of human intention. We're just adding another tool to do that. That's why people should not get upset about AI generated code. It is just another layer on what we've already been doing. So they used to do this back in the 40s and 50s, maybe even the 60s. And in some rare cases, they still have to do this, right? And then over time, they found out ways to reduce this and do more of this, right? This is the explosion of software development in the 80s and 90s, all the way up to present, is this, right? And so then now we got this to try to sharpen this. This is at its infancy. That's why it's still rough, right? So this is still very rough. This isn't polished at all. We're trying to polish it with these methods here to polish this, right? So it's going to take a long time. It took, 20, 30 years to get from this to this in any real polished way. And there's no reason to believe that the jump from here to here in a polished way, the way that this to this is polished, there's no reason to believe that this is going to be any shorter. It only looks that way. What it looks like is not what it is like, right? So that's the core. I've just verbalized the core intuition of thousands of software developers. This is what they're saying when they're saying that there's AI slop in software development, is that the level of precision of thought that programmers have learned to be able to put into source code to make a program is not available right now with what they're calling AI. But here's the thing about that. Even with that, there are some of us that have worked on our ability to communicate with humans. And because AI is supposed to be a rough approximation of human communication, not human thinking. Because as I said in my previous video, this doesn't think, it's just statistics. But you can bend the statistics to your will. That's what distinguishes those that can use AI well from those that can't, is the extent to which you can bend the AI statistics to your will. That's the whole goal. In this much the same way that when we're writing this human written source code and it's getting translated to programs, we are bending the computer translation to our will ultimately to make a computer do something. It's the whole thing. And what are we making a computer do? We're making it, produce spreadsheets. We're making it calculate attendance and PTO programs. We are making it calculate sales commissions. We are making it figure out the velocity an electrical vehicle should go at in order to stay on a safe trajectory. We are using we're using these source codes to build processes that make the computer do the things that we humans find valuable, such as to even make video technology possible in the first place, right? So that we can communicate information. So that's why I'm saying that individual competence remains the centerpiece of using the AI effectively. And we call it AI, and the name is probably going to stick, but we know what it really is. It's just a statistical transformation tool. And then we got people now, they are creating things called Kilo. You can't really see that well, but there's this new thing called Kilo Code, right? Kilo Code. And so what Kilo Code does is it's a open source I just learned about it today, but it's like a competitor to Claude Code. And so it is truly built by software developers for software developers. And it is one of the most impressive free and open source coding tools that I've seen out there that is going to leverage AI in a more effective way. I did spend considerable time yesterday doing some deep research with the assistance of DeepSeek to understand running AI on my own computer. So I'm like, maybe I don't use Claude Code, or I don't use ChatGPT or Google Gemini. Maybe I don't use any of that, and I just run AI directly on my computer, right? Because there's open source AI, right? You can download it and you can run it right on your computer if you have the programming skills, which I do. So I got the skills to run AI, but I found out. So DeepSeek saw my questions, and it was a good. It started out with me asking very deep questions about Google anti-gravity and Notebook LM, which I am still interested in those, right? I'm interested in Google anti-gravity and Google LM. So I'm probably going to investigate that, if not invest in that. But if I do use a commercial AI tool for software development, it's probably going to be Claude Code. As I mentioned a couple of videos ago, I'm contemplating adopting that. But Kilo Code might change that. I might just say, hey, I can just use Kilo Code. The way I would say it right now is Kilo Code would then be the Linux of agentic coding AI. Agentic coding AI, right? And so I'm rooting for Kilo Code to do some great things. So in my research and my intuition and just being able to put things together, read between the lines, you don't really need to pay for these AIs if you have the programming skill and the IT skills to download the AI models and run them on your computer. But there's a catch. There is a catch. Okay? So let's walk through that a little bit. So AI, local AI, right? Local AI. So you want to run AI on your computer. All right. So, okay. So you got your computer to run AI, right? So here's your computer. And so you got to do a couple of things. You're going to put a model, an AI model on there. You're going to use a tool, right? This is your runner, right? This might be something like Olama. I know I spelled it wrong. Anyway, Olama. So Olama can load these models, and it has access to your files that you granted access to, right? There are no security issues with any of this, right? So it's all local on your computer. And if you really needed to verify it, if you're a software developer, you can actually get the source code for these things and just build it yourself. So you can fully gate this where it's all just secure, dare I say it, proprietary, right? You can have all of this here. You can build all kinds of trade secrets on AI and all this kind of stuff if you really wanted to. And when I say model, so you can download these models. So you can download the Gemini model. You can download the DeepSeek model. You can download the Claude Opus model. You can download the the GPT model used by ChatGPT. You can download these to your computers. You're not even on the web anymore. You got full control over the AI, right? And it looks great. And I had been thinking about this for a good while, but there's a catch. There's a catch. So what is the catch? The catch is that in order to run the AI locally and run it well, okay, these AIs, they are their own. These models are they're their own database. So they're their own database. So depending on what model you download, you might need 200 gigabytes of storage space. If you got a terabyte or 2 terabytes SSD, I mean, that doesn't seem a lot until you start messing with a couple of them, right? So you say, oh, I'm just going to deal with one of them. Okay, that's fine. That's fine. But then keep in mind that you're trying to generate images. You're trying to generate code. You're trying to generate all kinds of stuff. So then your local files will explode, right? So now you got to account for that storage, right? So you gotta keep in mind that you might be dealing with a 500 gigabyte, 1 terabyte situation, if you have that, if you can even afford that, right? But here's where it gets interesting. So now we've talked about storage, but what about your CPU? You're gonna need a good CPU to run this. So you're gonna need a level 7 or 9, right? And I know Intel doesn't use these numbers anymore. AMD doesn't quite use these numbers, but you need a Ryzen 7 or an Intel Core i9 or something like that. You need a Threadripper, right? And preferably as a desktop, not a laptop. So you're not really going to run these AI models on a laptop. The closest you can get is maybe a Z series laptop from HP that's used for like engineering, or a Dell Precision mobile workstation, or a real upper grade Lenovo ThinkPad, right? You can't buy these computers, at a retail store. But even if you were able to get the CPU situation squared away, RAM, you need between 32 gigabyte to 64 gigabyte. But I'm not done there, because this is where it gets interesting. So even with all of that, and you can buy this, you can get this combination at a retail store. You can buy it online, have it shipped to you, right? Maybe you spend $1,500, $2,000 to be able to mess with the AI like that. Not mess with it, use it productively. Like really use it like you would use it if you was using it on the web, but you're doing it locally. You are only going to be able to use the small junior versions of these models, because the junior versions of these models can fit in that. The junior versions. So the web versions, they're much bigger. So they can do all this stuff. All the stuff that you see Gemini do when you use it on the web, or Claude when you use it on the web, or Claude code, because it's connected to the cloud. All of that, you're not going to get that when you download it. You see these videos on YouTube and other places where people, they got this local AI, they spending $10,000 for a computer to even mess with this in a more productive way. That's not accessible to most people, and that's not accessible to most programmers. Most programmers, despite their income level, don't have it like that to just throw $10,000, $20,000 around just for the opportunity to use something where they are saving $20 a month. Okay, even $20 a month, right? For 2 years, you spent $600. You still, you still saved, you still saved a lot more than you did trying to run this locally on your own home lab. So don't be misled by influencers and creators that, you're not getting the full story there if they haven't disclosed this part. So then how do you run the full AI on your computer? So here's what ends up happening. So you can't do any of this. The RAM is what gets you the most. This is what's going to get you the most. So you might need 200 gigabytes, not 32, but you might need 200 gigabytes, 1 terabyte of RAM, even to get started with something. So I was like, hey, DeepSeek, what would I lose by using the junior models compared to the cloud models? What would I lose? And it was very honest. It was like, hey, you trying to write some code? You try to make some HTML, you might lose some angle brackets. You might be missing some pieces. And so some of the output would be crippled, would be handicapped because there's not enough capacity for the AI to complete a thought. There's not enough room. So this is why that's why everybody's trying to build these data centers to do AI, because they need all this RAM, all this storage in order to run this stuff, right? So in order for you to be able to run this model yourself, you have to be one of those well-compensated software developers and consultants that have one of these really good jobs at a FANG company or a large corporation, or you're like one of these very successful freelancers, and you can afford to just buy you some servers, right? You got your own little servers, or maybe these Mac Minis, right? Not Mac Minis, Mac Studios. A Mac Studio starts at $2,000, right? And then to really trick it out so it can run AI, you're looking at about $10,000. And so then you get a couple of these. Before you know it, you just spent $40,000, $50,000 just to run AI. I'm like, no, I don't think so. I don't think so at all. So that's the problem with trying to run local AI. And that is why, for the foreseeable future, even though they're trying to work on good AI that runs small, and you can say, oh, well, maybe I would just get the AI to just do code. You got some significant problems there. You're going to spend just as much time trying to set up a local AI to fit within a typical home, desktop, or laptop computer or work computer. You're going to spend just as much time getting the knowledge together, getting it tuned and optimized, not to mention to stay up to date with updates to the knowledge, as you would working on your projects in the first place. That's what I realized. It's like, so when we are thinking about AI, we got to think about, this goes back to something I said in an earlier video. Return on investment. So you got your amount of effort leading to result. Depending on the results you're trying to achieve, that could influence the amount of effort and the nature of the effort that you need to put in to achieve that result. So what if, thinking about this in a more sober way, you say to yourself, okay, what we call conventional, not traditional, because traditional implies a level of obsolescence, which we're not there yet, but conventional software development and work practices And we know what the results of those are. Programs, systems, and enhancements. And I'm not advocating for things to remain the way that they are. Not at all. I'm at heart a futurist. So I'm all about future technology, sci-fi, all that great stuff. But I'm also one that has evolved in the real world, in this life. And I can see where we have some limitations with some of the things that we talk about. And the way that we talk about AI goes too far beyond what we can reasonably expect from it. To where if we buy into it too much and in the wrong way, we're going to find ourselves missing current and present opportunities, right? And I know that there are these, I see these creators, I see the videos where the person says, hey, you can copy a $15,000 website for $0. Hey, I've ran some successful startups and I'm using AI as an accelerator. So I'm not talking about them specifically, but there is a verbal pattern and a way of moving that is very much similar to running a grift, running a scam. Not saying anybody's running a scam, but where you are basically gambling and you are working with images, shadow, and appearances that do have some tangible basis. Maybe you can make some marketing websites for some people, and it costs you. It won't cost you $0. That's very misleading. But you can do it where you can basically use AI where you can create these marketing websites for $10,000 a pop, but it didn't cost you $10,000 of effort to do it. And if you do enough of those within a 12-month cycle, you can make $1 million. You can absolutely do that. And you can change your life with that. And you can also put out videos that are very convincing about connecting Notebook LM and anti-gravity and taking Claude Code to the next level. You can make some very convincing content about how you have leveled up. And those views on those videos is what's making you rich, not what you actually tangibly delivered to people that substantially transform their lives, right? And I'm talking about customers. You know, when you sell something to a customer, you should be improving that customer's life with what you're selling, right? And if you're selling dreams, right? When you are selling dreams, then the value of the dream that's sold is usually not as remarkable or as substantial as something that's tangible as a real service, like, dog grooming, or, driving somebody around town to run their errands, or, putting together a actual business strategy that improves profitability by 10%, 20% in a given quarter, right? Selling dreams doesn't have the same value, right? And that's where you can have bubbles. That's where things can actually implode and collapse. And so that's where we have to be careful, is that there's this phrase, FOMO, fear of missing out. Fear of missing out for you as a person can take you down a very bad direction. And so you should not fear about missing out on AI the way people are describing it. Because here's your test. Here's your test. What proof do they have with what they are advocating? And I'm not talking about building a web front end. We've always had people that could build web front ends going all the way back to the late 90s. That's how I started my career in software development. I was a front-end developer. I was good with the HTML, the JavaScript. I used JavaScript when it in the first years that it came out, right? That's how far back it went with me in web development. I have more web development experience than I do .NET experience, and I've been using .NET for 24 years. So, so my origin in software development is in web development. And so, and I built some front ends using Ajax, hand-coded Ajax, handwritten. So we've always had front end developers. You can always do some web agency stuff, and it looks like success. And then I also have been around to see many web agencies crash and burn, because web agency work back in the day wasn't always a sustainable business. It had problems. So you can't really impress me with you built a front end, right? You impress me when you have built something that genuinely transforms people's lives and provides real value on an ongoing basis for those customers, right? And none of the, I'm going to say none, I don't know all of the creators, but none of the creators I've watched, I watch videos on these things because there's some good ideas even in something that might be overhyped. So I watch overhyped stuff. I look for those little moments of insight, right? Because even in hype, there's a little bit of truth. You just got to find it. But I don't see no apps. People do these nice videos about, oh, look at this anti-gravity thing. Look at this notebook LM thing. Look at this Agent Zero thing. Listen, show me that you can use AI in real time, or the end result of you building Microsoft Office. I'm using an example. Did you build Photoshop with AI? Did you build Microsoft Office with AI? Did you build AutoCAD with AI? I'm just using those examples. Those are substantial computer programs, right? Show me a really slick and in-depth mobile app that you built with AI. Show me a website from start to finish that services 1 million customers a day that you built with AI. And show it to me. And show me you doing it with AI. I bet you can't. They don't ever show you that. They just show you the romanticized, glorified description of these tools so that they can get views on their video and they get paid their money. So that doesn't upset me. It would have years ago, but it doesn't upset me. I understand, and like I say, there's some value in the promotion of these tools and these concepts. But I say for myself, I don't allow myself to get reeled in too much, right? I was a few months late to ChatGPT. They talked about this in November of 2022 or something like that. And I was like, oh, okay, that sounds interesting. They said, oh, it got 1 million people in like 30 days or something like that. Whatever that initial hype phrase that was. And then one day I was like, well, let me try it out. I was like, oh, I'm just going to try it. And then it grew on me, right? And then, like I said recently, I outgrew it. And so the thing is that where is the substantial value? What have you made? What have you actually delivered? And so, and people would be wise to look for the real proof, to see how it actually would work for them, work for you. But I do see AI as a useful skill, and I see it as transformative. But if you build your success on sand, on a house of cards, then you cannot be surprised by what you can expect when the results don't hold up over time. And you end up like You end up like one of those chronic gamblers who you got to keep moving to the next fix, right? In order to keep yourself afloat. I've seen some successful people that work in that way. And, this is not to criticize how they survive, because surviving in this world can be very difficult. But, there are some of us, we look for things that are sustainable, things that we can be proud of, things that we can put our names next to, and things that we know that will be a foundation for us to pursue other things in life without constantly having to come back and worry about, okay, this isn't working. We need to find the next big thing in order to, and we're seeing this with major corporations. We have some major corporations, they're doing a version of this, and it's not looking well for them, right? And I've talked about that 2 videos ago, I think it was 2 videos ago. I talked about that, or at least hinted at it. And so that's kind of my thoughts right now. I've been looking into running local AI. I've been looking at what is going on with AI coding. And don't mistake what I said that I have written off AI coding. That's not what I said. I said that it's a good tool if you can use it right, and if you still have the core individual competence, right? Because if you build something you don't understand, and these are not my words, but it made sense when I heard it. If you build something you don't understand, then you can't really maintain it. You can't really cultivate it and grow it into something better, right? And understanding comes from education. It comes from practice. It comes from very, very real, tangible skills. And so that's the insight that I have on this. And, if I do talk about this more, if I decide to talk about this more, I'm going to drill down more on this aspect here than anything else. But until then, I'm surprised I did this all in one take. But I thank everyone for listening who was able to listen, and I will catch you later.